As you very much know, large language models have boomed in the past months and years across a lot of sectors and industries, and they have uncovered new capabilities every day. But much is still to be explored in terms of how LLM can be used to model systems for the good of all humankind, and particularly in science and meteorology. The foundational model Adaptors for Disaster team aim to use LLMs to improve decoration, extraction, interpretation, and dispatching of key insights regarding natural disasters in order to deliver information to disaster management teams in a more timely way and grow our disaster resilience as a society. The team has chosen to focus their work on one of the most impactful disasters in the world, flooding. By combining Earth observation, flood prediction models, flood mapping tools, humans-in-the-loop methodologies, and weather monitoring system with LLMs, they endeavored to create an NLP agent that could generate accurate and tailored flood reports used to assess disaster impact across the globe. They've been hard at work this summer, and on behalf of Google Cloud and myself, I'd like to really thank them for putting all their effort in this worthy pursuit, and to boldly chart a new area where LLM can be helpful and impactful for all humankind. Thank you so much.
Thank you, everyone. It's a pleasure to be here today to talk about the work that the Foundation Model for Disasters team have done over the last 8 weeks. I'll start by introducing our team. The researcher team made up of Paul Dahm and myself, Grace Colvard, both of us PhD students working in AI, have been supported by our wonderful faculty members, Noah Kazmanov and Leo Silverberg. In our talk today, I'm going to be introducing the problem we focused on, the challenges we face and how we tackled them, before handing over to Paul, who will talk about the solution we built and how we hope to see it used. In the past 2 decades, we've witnessed the formidable power of nature, but there's one natural disaster that stands out in its frequency and impact: floods. With the combined force of climate change, deforestation, and urban sprawl, our vulnerability to flooding has significantly increased. Regions that were once considered safe from floods are now regularly inundated, to the point where almost a quarter of the world's population lives on a floodplain. It's probably not a surprise to all of you to hear that the frequency and severity of extreme weather events is increasing due to climate change. But you may be surprised to hear that over the last 25 years, floods have affected more people globally than any other natural disaster. For us, this wasn't just a statistic, it was a call to action. We've identified the part of the flood response where our team skill set could provide the most benefit. After the immediate response to the flood is over, there is a period of research and investigation. The flooded areas are mapped and impact reports are written in order to provide aid agencies with information needed to make relief decisions. You can see here on the right an example of a one-page flood summary from the UN's OCHA agency. These flood reports take time and skill to create, and relief agencies have a limited amount of manpower available. Our challenge was then to automate this part of flood reporting, or in other words, use machine learning to aid in the creation of accurate, fast, detailed, and useful flood reports. The type of machine learning we have used are models called large language models. You may have heard of chatbots like ChatGPT or Bard. LLMs are the engine behind these chatbots. In simple terms, LLMs are next word prediction engines trained on huge amounts of textual data. State-of-the-art LLMs are successful in a whole manner of tasks that you can see here on the slide. We chose to use LLMs due to their success in text summarization, question and answer, and common sense reasoning, tasks that are critical in creating flood reports. By offloading parts of the report creation to LLMs, we reduce the cognitive load for report creators at aid agencies. Flood report creation generally follows the following timeline. After the event, receiving satellite data and mapping the flood extent takes at least 2 to 3 days. Following that, the investigation period can take up to 4 weeks before a flood report is created. Our research showed that LLMs can help with steps throughout the whole of the flood report creation process. And now I'll hand over to Paul, who's going to introduce the tool that we've built.
Thank you so much, Grace. Hi, I'm Paul, and now it's my great pleasure to introduce to you our tool, FloodBrain, that we have been working on hard during the last 8 weeks. It contains 3 features. First, it generates a situational flood report. Second, it also provides a map which brings more context to that flood. And third of all, it also has a chatbot functionality, which allows you to interact with the tool. But before I talk about all these features in more detail, I first want to talk more about the main pipeline that you use to generate the situational flood reports. So obviously, we were inspired by how humans extract information. And just to showcase the simple process, in case you're interested about a specific flood, you might want to ask how many people have been affected during this flood. You obviously do a Google web search, you find the website, you extract the answer, and then based on that, you can write this in your flood report. And this simple sequence of steps, you can imitate with a large language model. So similarly, you can automate the Google web search. You can then extract the information from the website, use this as input into a large language model, which then allows the large language model to write an answer which answers your question. Now, the cool thing about using large language models is that you can obviously automate this process and parallelize it. So you can be way quicker than any human could ever be. And at the same time, you can also provide not just one answer, but 3 answers to the same question, which already gives you some form of robustness by allowing you to easily check if your answers are correct or not. Now we scale this even further. And obviously, when you create a situational flood report, you might be interested in not just asking about one question, but actually about multiple questions. For example, what is the severity of the flooding? How much rainfall fell during the flood or shortly before? Or, which goes hand in hand with that question, what was the cause of this flood? Now we can take all of this information, all of these answers using the same pipeline, use that information and use it as input into another LLM, which works as a summarization tool, which then creates you this very nice coherent flood report. Now, by speeding up the process, we obviously reduce the time to create such a flood report. And as everyone will probably understand, time is an important asset when we talk about disasters. So now I want to show you how this tool looks like on our website. So again, you can see our flood report. And what you can also see is a list of URL links, which show you where we got this information from. And this already tries to tackle one major problem with large language models, which is that sometimes you're not really sure where they got their facts from. In this case, by constraining the output of the large language model to take its inspiration from the websites, we already constrain it in that way. And we also allow the user to easily check if the information that he provided is accurate or not by going to the websites. We took this another step further by not just providing the websites, but actually implementing a relatively easy or simple but effective pipeline, which allows the user to inspect directly the websites. We call this inspect. So for this example, you can see for the question, who has already responded to this flood? You can see FloodBrain's answer, Italian Civil Protection System. And you can also see a snippet from the website where we found the large language model based its answer on. And what we hoped of achieving by this is allow the user to see the transparency or be more transparent in producing the output, and in return, increase trustworthiness in the tool, and finally, hopefully increase the usefulness of our tool. Now, these flood reports are great, but sometimes you also need to provide a bit of context in the form of a map. And this is exactly what we did. We also provide a map with the area of interest for each flood. What we also employed was a machine learning pipeline, which was developed during a previous FDL flood challenge called Flood Mapper. This pipeline compares different satellite images and creates a flood map, which allows the user in return to easily grasp which were the most affected areas during a flooding. We also provide additional metadata such as a population density, residential areas, or roads, so the user can easily understand where to put where to target his efforts on. Now, obviously, no modern website would be complete without a chatbot, right? So this is exactly what we also implemented. Now, this chatbot actually has a real background because while developing, we spoke to some experts and they talked they told us that they would be interested in personalizing, customizing the flood report. And this is exactly what this chatbot allows you to do. It uses the same pipeline components that we developed for the summarization part, but allows the user to ask his own questions. So for example, for this example, here we ask the chatbot what rivers were overflooded during the flood. And you can see the chatbot gives its answer and also provides a URL link again for the user to check out himself. Now I want to show you how this all looks in the wild. So putting this all together, this is our user interface on our tool website, floodbrain.com. On the left, again, you can see the chat. In the middle, you can see the report, and on the right, the map. And you can check it out just now by going to floodbrain.com and entering our password, floodbrain. And this is exactly what I would invite you to do after the showcase. So if we go to our website, you can just start off by generating a flood report, which is very easy. And you could also use our evaluate feature, which would allow us in return, maybe in the future, to train our own large language model and adapt the output to the preferences of our users. And with that, I want to go back to the timeline that we showed you in the beginning. So if we compare the timeline that would take a human to do the report to the one of FloodBrain, we can see that we have a huge increase in efficiency. We are especially proud of the significant reduction of time of creating the situational report, which takes sometimes days or weeks to now just under 1 hour. Basically, the moment a news website releases an article about the flood, we can start FloodBrain. And obviously, by reducing this time, we can use the time hopefully more efficiently to help people and maybe in the end, even save people's life. We are currently in conversation with humanitarian relief agencies, such as OCA or the World Food Programme. And we're really excited to see where this could bring us in the future. And with that, I want to thank our partners and sponsors, FDL, and obviously also the audience for tuning in today. Thank you.
Thank you so much, Paul and Grace, FM Adapters for Disasters team, for that wonderful presentation. We're going to move on to our faculty thoughts portion with Leonard Silverberg from Trillium Technologies and Noah Kasdanoff from New York University. So Leo, maybe we can start with you. What excited you about that presentation?
Oh, so much. What exciting work. I want to, again, thank Paul and Grace and Noah for the last 8 weeks. It's been amazing. Something that really stood out to me over the last 8 weeks has been the sort of ability to innovate in public, if I can say that. We've been deploying this tool live as we've been building it, and that's been super exciting, being able to use these state-of-the-art language models and all of that. Of course, thanks to Google Cloud, has been super crucial to the development of this. Something else that really stands out, I think, from the presentation is the transparency component. I think that's something that I haven't really seen that much other people do, and it's very interesting, this sort of inspect tab and being able to see the thought process of large language models, how they make their decisions and how they decide on what information to show. I think that's super exciting. I'll hand over to Noah.
Yep. Thank you, Leo. And yeah, first and foremost, just completely echoing everything he said there. Thank you to the team. It's been an awesome past 8 weeks. I think what really excited me about this presentation was just sort of the blend of research and integration that took place and was so perfectly captured here. So as Paul mentioned, this website demonstration, so that this is accessible for anyone to use and play around with. I really like how Leo mentioned how it's sort of developing and iterating in public. So yeah, it was really exciting to see that. And then at the same time, identifying the limitations and capabilities of these large language models for this specific but very important use case was really important, and I think a research challenge that is not specific to this domain.
Mm-hmm. And what do you see as next steps for this research, Noah?
I think there's so many different things. On the technical aspect, I think one aspect is potentially using an open source or publicly available language model and trying to see if there's even an opportunity or potential to use that rather than these closed source tools, which while very powerful, have their own like caveats and limitations. But then also, I think what's really exciting is there's sort of a new type of research which is evolving out of this for us, which is understanding, as was mentioned, like the partners and humanitarian agencies and others who may be interested in using this sort of tool, like how do we tailor it to their use cases? And I think this is sort of like the industry sort of problem that's a little bit outside of academia as well as our comfort zones, which I think is really great to embrace the challenge of and see how far we can take this.
Yeah, it's super cool, right? And I think we can all imagine what this sort of tool could be applied to other than floods. You could sort of like think of other humanitarian relief situations where you would want situational reports, like wildfires or earthquakes or, you know, anything like that. I think we can strive towards that, and that's very exciting. Like adapting this pipeline to all other kind of situations, super cool.
I agree. And thank you, Leo and Noah, for your kind words, your excitement,